Welcome to MAKE, Hands-on Intro to Engineering Design, a course taught at the University of South Florida. This video will discuss how to make a technical drawing from a 3D part in Inventor. Hi, today I'm going to be showing you guys how to draw a technical drawing in Autodesk Inventor from a part that you've already created. This will allow you to make a drawing that you can give to a machinist and have them make you the part. So I'm going to be using this model of a stepper motor. It's a stepper motor that you can purchase from SparkFun Electronics, and I actually made the 3D model from a technical drawing that was provided from the SparkFun website, and you can see it here. And so now we're going to do the inverse and create a technical drawing from the part. So we'll go back to Inventor and just get started here. I'm going to go up and actually select Control N for a new file. This is going to bring up the new file dialog, and we can go down here to the drawing section and select one of these drawing templates that we're going to use. I'm just going to use the ANSI millimeter drawing DWG file. That's the standard Autodesk drawing file, the AutoCAD files, and I'm just going to hit create. So this will bring up our blank document, and we can start to place some of the views that we want to be displayed on the drawing by selecting the Place Views tab and then selecting one of these Place View commands from the ribbon. So we're going to select Base View, and since the stepper motor part file is already open, you can see that it brings up a preview, and this is the file. This is the part that we're going to replace. If the file wasn't open, you can go here and select the file that you would like to open, and it would do the same thing. Right now it's drawing this at a 1:1 scale, and we actually want to be able to display a little bit more information. It doesn't really take up much space, so we're going to go down here to the scale selector here and select 4:1, and that seems like that's a little bit better drawing, and so we're going to click that, and as you can see, it's placed the drawing. And now if I move left or right, it will place projected views depending on the direction I go. So if we want to remake this technical drawing, we're going to get a view with the shaft pointing to the left. So I'm just going to drag the view over here, click, left click, and then I'm going to right click and hit create. And this will place my views, and now I can actually take this view by selecting the border here and dragging it over, and now we have the views placed in the proper location. If you notice, as I drag this view, I can move it around, and the secondary view, the projected view, will actually follow it so that the two views become aligned. I actually want to place a third view here. We're going to select base, and it's going to be an isometric top right view. If I put this down, 4:1 is a little bit big. We can go down here. Let's see what 3:1 looks like. 3:1 is still a little bit big. We'll go 2:1. So that's perfect. We're going to click it there, right click, and hit OK. And then I'm just going to move this over here. So now that we have our views placed, we can start to customize the look of each one of these views. So with this view, I'm going to double click on it here. I'm going to select its style and select it as shaded. This will give us a kind of more realistic view of the actual part in this view. For this view, I don't want to display the hidden lines, because as you can see on this drawing, the hidden lines aren't really necessary. We know they're holes according to this specification here, and so we don't really need to see the hidden lines. It doesn't add any detail. So I'm going to double click on this view here, and I'm going to go down to the style area again, and this checkbox here says style from base, and since this is the base view, it's inheriting the style that the base view is associated with. So I'm going to click that style from base. I'm going to select here hidden line removed and hit OK. And so now you can see these views are looking almost identical to how they are displayed in the datasheet. Next, I'm going to add some center lines. These will identify the holes, as well as the center line of some of the circular parts of the motor. So I've added center lines to all of the holes, and I did that just by clicking the center mark here, this button. So now we have a center line. I'm going to click that, and I'm going to draw this center line here from this point to this point. Hit create, right click and hit create. I'm going to select the center line again. I'm going to draw it from this point to this point. And then again, hit create. So now, if you look at this view, it is nearly identical, aside from the dimensions, to the part on the datasheet. So now we can start adding some dimensions. First dimensions I'm going to add are the spacings here between the holes. I'm just going to select these two hole sizes. And if you notice, as I drag the dimension out, it will actually snap to certain positions and show a dotted line. And in that way, you can keep the distance from your part pretty equal compared to when adding multiple dimensions. And this makes the look of your drawing feel a little more uniform. So I'm going to click on that, and this is going to bring up the Edit Dimension tab. So really, what we're most worried about here is the precision and the tolerance tab. So if we go back and look at this drawing, we can see that these dimensions have a precision of a single millimeter, and then the tolerances here are generally in the tenth of a millimeter, according to this dimension specifically. So we'll go back, and our primary unit, we're going to use whole numbers, and the primary tolerance is going to be single decimal place. And then we're going to go here to symmetric, because it is plus minus 0.1 millimeter. And say 0.1 and hit OK. And so there is our first dimension. And we'll go ahead and dimension these as well. Same thing. And again, we can get it to snap. Primary unit is single decimal, or no decimals, and then the primary tolerance is a single decimal. Again, it's symmetric, and 0.1. We'll hit OK. So now these are looking as they should. We'll get our next dimension here, and that's the outer, and that's going to be 42.3 millimeters maximum. So we're going to dimension these again. We'll select these two lines, and again get some points where they snap. The primary unit this time has a single decimal place, and this is a max, so we can select max and hit OK. 42.3, and we'll repeat this down here. Again, find where it snaps. Single decimal place, max, and hit OK. So now we've got these dimensions inserted. We can go and add the hole specification. So there's actually a tool dedicated to the hole and thread notes. So we'll click on that. We'll go down here and select this hole, and we'll drag the leader down and click it. And as you can see, it now says the diameter is 3 millimeters, and the depth is 4.5 millimeters. So we're going to hit OK, and then we're going to double click on this, and this is going to bring up the Edit Hole Note dialog. And so this basically allows us to format what is displayed for this hole note. And so if you notice over here, they have the number of holes as well as the thread designation. So we're going to include that in our note here. They actually provide us a button where we can give the quantity, and so we'll hit that. It brings up this little quantity note tag, and then we're just going to put M3 as our designation. When we hit OK, you can now see that we have a diameter of 3, depth of 4.5 millimeters, 4 times, and an M3 designation. So that's exactly what we want. So now we can see that the base view, that is done dimensioning, and we can go over here and add some dimensions to this projected view. So we'll start up here with the top two. We have 34 millimeters max, and then 24 plus or minus half a millimeter. So we'll go here and dimension this line. Again, we can get this to line up with some of the snaps. It's a whole number, and it's a max, 34 max. That's how it is labeled here correctly. And we'll label this as well. From this line to here. Oh, I selected the wrong one there. 24. And that is a whole number, I believe. Yep, and then it's a symmetric tolerance of 0.5, and the tolerance has 1 decimal place. So we'll hit OK, and that looks good. We now have to dimension this 2 millimeter and then the diameter of the 2 circular components on this view, and then we will be done. So we'll go here to dimension, we'll grab this line, drag it out, 2 millimeters. The primary unit's a whole number, and there's actually no tolerance listed on here, so we're just going to say 2. And now the the dimensions, the diameters, I'm sorry, you must select a circular component to get a diameter. So if you were to select these 2 lines, it will label it as a distance, but we want it to actually know that it's a diameter, and so we can click the circular component. It adds the diameter symbol, and which is what we want. So I'm going to click that. The tolerances on this one are a little bit different. It's a whole number as the main unit, and then we have 0 and 0.013. So these are 0 and 3 decimal places respectively, and then there's actually asymmetric tolerances. So the upper is 0 and the lower is 0.013 millimeters. So we'll hit OK, and we can see those 2 dimensions. That is correct. And finally, we have to dimension this disk here. We'll click that. Again, since we clicked the circular part, we will get the dimension, the diameter symbol. We can click that. It will bring up the precision and tolerance, and we'll go over here. It's a whole number, and plus 0 and minus 0.052. So select these again as we did in the previous one. And there you go. That is how you take a part and turn it into a drawing with dimensions. This concludes our tutorial. Thanks for watching.